Okay, in this video, we do the last topic on prescriptive analytics. Actually, this could either fall into prescriptive or predictive. I'm going to put it here, and it's the focus on spreadsheet simulation. And the thought is that we're going to turn Excel into the ability to generate random numbers, and when we can do that, we can do what-if scenarios where we model variability. How noisy a system is. So you can go do a research on spreadsheet simulations. Again, there's tons of videos out there. You can see how to do that. You can also, the problem that we're actually going to solve in class in this video is the Newsboy problem. It's the news vendor or Newsboy problem. And if you would go do a search on that, the news vendor, it's an inventory problem. And you can solve this thing using equations, but we're going to solve it using spreadsheet simulation. And its sole purpose is you get one shot to determine how much inventory to have, with the thought that your inventory loses its value drastically after a certain time period. So the example that we're going to do is think about this as calendars. Think of these as annual calendars that have January, February, all the way to December. And we know that we're going to sell them for a certain amount. And the cost to produce them is a certain amount. And then, but they're not worth very much after that year. So if I was trying to sell a 2020 calendar and it's in March, well, it's not worth anything. I probably can't sell it for what I want to. In fact, what my salvage value or refund value is always going to be much less than it actually costs. So it'll let me recover some. In this case, it looks like that we're selling calendars and we want to put them on the shelf for $10. For every one we produce, it costs us $7.50. And then after the beginning of the year starts, we can send them back to the publisher and recover $2.50. So these three cost drivers impact what we should do. And we expect to sell 200 calendars, but there's variability to that. Sometimes it can be larger because the standard deviation is bigger. So if I would take this number plus or minus 3 of these, I can see that my range of values can be probably between 170 and 230. I might sell more than 170, unless I'll probably always sell more than 170, but I'll probably never sell more than 230. Okay, with this stuff in mind, and these, the primary thing is how many should I buy? How many should I put on my shelf? So in this case, this is a number, it's just an input. So all of these are just inputs. This is given information, and this one is I'm trying to figure out how many calendars should I put on the shelf for people to sell. If the demand is 200, well, or the average demand is 200, I'm going to put 200 out there. So let's see if that's a good idea or not. And what I'm going to do is I'm going to simulate the annual demand many, many times. I'm doing it in this case 40 times. Okay, so how did I do that? So for the first simulated year, for trial 1, I generate a random number, and this is the formula that I used. And that generates a number equally likely between 0 and 1. So all of these numbers are between 0 and 1 equally likely. So sometimes they're high, and sometimes they're low. If they're high, I get an average, or I get an actual demand that is bigger than the average. So that one's bigger than the average. And when the numbers are low, I get a demand that is lower than the average. So how is that working? Well, this is the formula that I'm using, this formula, and you can see what I'm doing is I'm using the norm INV function. Will generate a value from a normal distribution given the mean and the standard deviation. That's what this is and this. And I wanted to generate that randomly. So I'm generating based on this random number. So when the random number is high, I get a high demand, and when the random number is low, I get a low demand, like that one. I'm also using the round function, so it's rounding it to a whole number. So here's what we've got. I've got 200 on the shelf. In my first year, the demand is 215. I should have had 215 calendars, but I don't. I only have 200 and I can't reorder. So from that, I know that I'm going to sell 200. I only have 200 on the shelf. 215 people walk in and says, hey, I want to buy a calendar. Well, for 200 of those, you say, here it is. But for 15, you lost sales. The next time that I simulated it, the demand is less than 200. So I can only sell what my demand is. This one I sell what my order quantity is. This one I sold my demand. When the demand is bigger than the order quantity, I sell the order quantity. When the demand is smaller than the order quantity, I sell the demand. Well, how did I do that? I just used a min function. The min of this and this. And that's how I determine how many calendars I sell. So this tells me how many I'm going to sell. So if I take that and multiply at $10, that's what my revenue is going to be. But I also have salvage value or refund value. If I have an extra one, like this time, the demand is $1.99, so I sold $1.99. Well, I have one extra, and the producers are willing to take that back for me and give me $2.50. So I've also got an excess that I can sell back for my refund. And when that number is really light, these numbers are big. When the demand is bigger than that, I don't have any excess. I sold them all. So there's my two sources of revenue, selling it at retail and selling them at refund. So my revenue value is this value times 10 plus this value times $2.50. Well, my cost is how many calendars I buy multiplied by the unit cost. And that never changes. So just copy that formula down. So if I have my revenue and cost, I can figure out my profit. My profit's just the revenue minus my cost. So there you go. I've run this model 40 times, and I can look at these profits, and now that I've run it 40 times, I can actually calculate what my average profit would be and my standard deviation, and I can also generate a confidence interval. If I want a 95% confidence interval, this is what that value would be. I'm using this confidence formula, where it takes 1 minus the confidence. So if the confidence is 95%, it takes 1 minus that to come up with 0.05. I have to put in my standard deviation, which is that, and I put in my sample size, which is that. And that will generate my confidence. So if I wanted to generate a 95% confidence interval, I can take the mean plus this to get this, and the mean minus this to get this. And these two numbers, between these two numbers, is a 95% confidence interval. I think that my order, if I let my order quantity at 200, then my confidence, I'm 95% sure that my profit's going to be between 437 and 471 bucks. Okay, perfect. Well, what if the order, but that doesn't tell us that we should order 200. That just gives us what the confidence interval is if we order 200. Well, let's go to another worksheet, which is exactly the same. In fact, these are all referencing the formulas from the 200. But in this case, I changed my order quantity to a different value. I don't know what the best answer is, but I can do 220. I can do let's make that 240, sorry. 240, I can make these whatever I want them to be. I can have as many worksheets as I want. I could create another one. And maybe, And maybe this one I go the other way. This is 190 and change this to 190. And for every one of these, I now have a confidence interval. Well, now that I've got, in this case, 4 different confidence intervals, I'm going to go to this summary worksheet. And let me go ahead and add the order quantity 190. And all this is I'm referencing those 3 values. Whoops, just need one of them. And then over here, I need to go and add that additional data point. So I'm going to start this on B. There we go. So look at this is the picture of my 95% confidence intervals. Based on this demand, based on these cost drivers, and based on my order quantity, this tells me my confidence interval. So let's look at what's happening. If my order quantity is 190, I am got very consistent profit. I am 95% sure my profit is going to be around 470 or so bucks. If the order quantity is 200, it looks like that the average is slightly higher, but I have more variability. This one, my average is actually going down, so it looks like there's not a benefit of having a larger order quantity. See how this works? Well, that's only that, but it's set up. I could go back here and I could change this to anything. What if we had more variability in the system? Let's make this 25. And maybe we change the cost where I'm going to sell these calendars for something that makes more sense, maybe 25 bucks. So I sell them for 25, I salvage them for those. This is what it cost me. Let's go look at what the picture is now. Well, very different. There's a lot more variability in my confidence, and the reason is because I've got more variability in my demand. But in this case, it looks like that it's actually beneficial to keep a larger order quantity. It looks like that this one actually is superior to this one. You could argue that it has more variability to it, it does, but it looks like it's a better risk or a better decision than carrying 190. And 240 has more variability, but it starts dipping down. So you have to make a decision on which of these. It looks like I would do this one. And again, if I hit the function key 9, I can see what it does, and it looks like it stays fairly consistent like that. So you got to decide if you want less risk and have smaller bands, or looking at that. And that's a decision that you have to make. But this is what this model gives you, is the ability to model uncertainty and see what the impact of uncertainty is, both on the average and how much variability is in the result. So try to reproduce this, and because one of your homework problems is modifying this problem. Thanks.